variables and data types. All right, so you should remember that a program needs to store the instructions of its program and the data that it acts upon while your computer is executing that program. So I want to just reiterate to you the concept of memory. We talked about this is an earlier lecture, but I'm kind of just summarizing here why memory is important and how, what it is. It is because it's directly related to variables. So you should understand this concept of memory, understand what the difference is between memory and hard drive. But we know that memory is used by programs. When a program has to send instruction to the CPU, it's going to use memory, and when it is also store data, it's going to use memory, and a program will definitely do both of these in order to be useful. This is called RAM, random access memory. Program store data and RAM, and they will opt for variables and data. They will also use hard drives. The difference between storing data in RAM versus a hard drive is when you store it in RAM, the data is going to go away when the computer is turned off or when the program exits. Now, if you want to store persistent data, you store it on hard drive. Program system may use data on the hard drive, but only usually for external data, persistent data, the data that retrieved somewhere. All variables and all data in the program itself is stored in memory. So memories, you can just kind of think of it as this ordered sequences of boxes. I was going to try to find a good illustration for this to help you. We'll go over this in a lot more detail and pointer, because then you really have to be visualize how memory is stored. But if you think of memory as just it's an external hardware type, and it's just like a little stick of memory that you can put it in your motherhood. And if you think of it visually, conceptually, it's just a sequence of boxes. Each box is full will be represented by the number 1. And when it's empty, will be represented by the number 0. And it stores binary digits. There are zeros or ones which represent true or false values. And each box is called a bit. So bits in memory are then grouped into sets of 8, which is a byte. So you are probably heard these terms bit and byte. They are important when they are related to memory because it determines the size of the data. So each byte has been labeled with a number that represents an address. If you have data stored somewhere in hardware, you have to know how to access it. And just like a street address where you live, you need to know how to get access to that memory through some kind of label. So all memory bits and bytes have an address. So 8 bytes represent an address in memory, and it uniquely references that byte. So that's how you can access the data and kind of want to visualize it. So again, memory consists of a large number of bits. That's a group of 8 called bytes, and each byte has a unique address. And your program will access that data usually through an identifier. But it can also use hexadecimal addresses. And when you have memory for a program, memories that use programs and memories that are on your motherboard, it will increase the efficiency of your program. If you have more memory and the memory is faster, the buses are faster, you can access the more memory. So 16 gigs of RAM, you probably heard terms like that. The higher amount of gig RAM means that program can store more memory and access it quicker. And remember, programs use memory because it's just faster. You have to store something on a hard drive much longer. And remember, we are executing 1 billion instructions per second by the CPU. So that's a lot of data that you may need to access. So how does this all relate? Well, it directly relates to this concept of a variable. And so a program is only going to be powerful if it can manipulate data. It's going to send instruction to the computer, but it needs to manipulate data. So in order to understand the different data types that you can use and how to create and name variables, you need to understand this concept of memory. And when you are writing program for it to be powerful, you have to then understand the concept of variables. how to create them, name them, and also this idea of a data type. Constants are types of data that do not change. They are always the same. They retain their values throughout the life of a program. So as long as that program is running, that data is always the same. Variable are the exact opposite thing. There are types of data that may change, and that's why it's called a variable. So values can change throughout the lifetime of the program. Different values for that variable, and variables and constants are stored in memory with an address. However, it would be really hard to access that memory and memorize all the hexadecimal addresses. So it's a lot easier to create variables that have meaningful names. So you can give variable names that represent the memory locations to represent the addresses. And that way you can access them and modify that data much easier. So for example, assume you want to store two values, 10 and 20 in your program. And at a later stage, you want to use these two values. What you would do with this data is you would first two variables with meaningful names, probably something like, depending on what the 10 and 20 represent, but it might represent ages. So you would say age 1 equals 10, age 2 equals 20. You always want to use meaningful names, and then you can store the value. So you create the variables with names, then you assign data to those variables, the 10 and the 20. And I'm going to show you how to this. Then later in your program, you can access those variables by their name to read the data. And you can also modify them later in the program to change it. As long as it's not a understanding. So as far as naming variable, there are rules in the C programming language for that you can name it. In C, all variables names must begin with a letter or an uppercase, underscores, not uppercase, underscores only. And then they can be followed by the letters, upper or lowercase, underscores, or digits 0 to 9. So for example, I could create a variable called JSON, my flag, my underscore data underscore another variable. These are all variables that start with either a letter or an underscore, and then whatever's following them is fine as long as case letters, underscores, or digits are considered. Here are some examples of invalid variables name. You would not be able to create a variable with these names. It will come running error. You would get an error. If you said temp $sign value, the compiler would give you an error because the $sign is not a valid character. So you can't use the $sign by space flag. That will give you an error because there's a space. You cannot give a space between these variables name. That's an error because you start a variable with a number. Cannot do that in C. Numbers in your static perspective. Remember, the compiler checks these rules, so they will tell you if you are writing in it actually an error too. It looks okay because it starts with an alphanumeric character. The problem here is its keyword. So programming languages have certain words that have a special meaning that you cannot use for names, and it is a specific data type for the C programming language. So you cannot use that as a variable name. So these are some examples of variables names that are not good. And I mentioned earlier that when you do create variable name, it makes sure they are meaningful. We talked about comments already and the importance of comments for self-documentation and understanding the code. And meaningful names are the exact same thing. If you have meaningful names in your code, it can increase the ability of the programmer. It's much easier to follow, and it's also help to understand that program and debug and documentation process. So use meaningful thing, and we're doing that throughout all the examples that we go through. So once we name the variable and we have a variable, what about the data, and that's associated with that variable, that's referred to as a data type. So some types of data in programs can be numbers, letters, or words. We just talked about how you can have 10 and 20 as values, and you can also having alphanumeric or the strings or characters. So depending on that type of data needs a way to identify it. So that it can do certain things. It really just affect the size of the data in memory, how it's stored. So a data type represents a type of the data which you can process using your program. Examples of types of data I mentioned: numbers, letters, and words. Those are represented by specific keywords in the programming language. So examples of keywords in C that represent data types are ints, floats, and doubles. And we are going to talk about these specific data types and what they mean in another lecture. Uh, but data types are important because you have to specify the data of a variable when you create it, and the data types are going to correspond to the byte size. And depending on the operating system, the architecture you program. So again, it all has to do with the size and how this stuff is stored in memory. The program needs to know, do I need to allocate 8 bytes, 4 bytes, 6 bytes, and it all depends on the data that's being stored. And the way that the program knows how to do that is you specify the thing. There are also this idea, or maybe you have heard of this, called primitive data types. These are types that are not objects and they store all sorts of data. In C, all we have is primitive data types because we have no, so everything is a primitive data type in C. Now, if we want to actually start using variables in our program, we first have to declare them. Declaring a variable means that you specify the type of the data, the type of the variable followed by the variable name. So use the data types of that thing. And this tells the compiler how a particular variable will be used by the program, and it will also understand how much data to store in memory, whether it's 8 bytes, 4 bytes, and so forth. So for example, there's a result ordered keyword in C named int that's used to declare a data type of type integer. And so if you wanted to create that in your program, you first have to identify the data type, the keyword, which is int, and then you have to have the same name referred to as identifier. Then at the end, you have to have a semicolon because C all is semicolon and all statements. So the actual syntax is like type, specify, or data type. Specify after with variable name followed by the semicolon. You can also declare more than one variable on a single line by using a comma, or you can declare variables on separate lines. It all depends, but there is a syntax for comma separated variables. And C requires you to specify all program variables be declared before. They are used to, so declaration is basically just telling your program that is what I have. It's not telling you how you are using it. And it's just saving this is what I have in my memory. I have a variable named out. I have a variable that's going to store a decimal and number, things like that. So here's an example. We have the type of the data, which is int, and then use variable name, and here just x, and then we have a colon. Another example, if you wanted to create multiple variables on the comma line, you can separate them by commas. So in this example, we have 3 variables of type int named x, y, and z. And this is called declaring variables. We have not assigned any data to the variable. We just said this is the variable that exists and will happen in the program. Is the program will create those 3 variables in memory, but there's no values for them yet. You can assign a variable of value by using an equal operator, and we are going to talk about this in more detail. We talk about that, but this is pretty simple and you should understand it. Assign a variable to a value, just use equals and then the actual literal constant of that type. So in this case, x is an integer, a decimal, so we assign it 112, and then we have the semicolon. That's assigning a value. In closely relating to assign a value is initializing the variable. Initializing the variable is basically having an initial value for that variable. It's important to initialize your variable because if they don't have any data, any values associated with them, it would cause problems in your program. So you want to get in the habit of initialization. And initialization can be done as a part of the declaration. Doesn't have to be. Basically, what happens is when you declare the variable and you say, this is my variable name, this is my types of variable, you can then immediately have the equals operator and then values variable followed by a semicolon. Like for example, index equals 21. In that case, you are declaring a variable named x of type int, and you are also assigning it a value of 21, initializing a first value, and that's initialization. Another example, the y equals 32, z equal to 14. We can do it on the same line, initializing two variables the same type, and into JAD equals 94 is okay to do by the compiler, but in this case, actually initializing both variables, only JAD will be initialized. X is not initialized, so Z is going to be equal to 94. X is not going to have a value, so that's important. And we are going to be declaring initialized variables all throughout our code. Let me just go and we'll bring up a simple project in code. Good luck. And I can show you how you basically can declare these variables, just like these examples. So here we are in code blocks. This should look familiar from our previous example programs. We have some comments at the top from line 1 to 6 through multi-line comments. We have some include directive on line 8 and our standard library below that. And then we have our entry point main routine on line 8, 10. And we are not doing anything in our program. Now, again, for a program to be interesting to do anything of substance, you are going to want to create and use variables. And there's all sort of different ways. Like now we don't really know all the data types. So we want to create many different types of data. We have really just had that in example, but just to reiterate, all you need to do is you have to actually with the intelligence and and so you type in the nice integrated develop environment, it displays all the other things that you can define with it. It actually completes I. If you to type an F, you would use maybe other completed words like a flow is another data types. But again, to declare a variable, you just say that data type a valid name. Remember, valid names start with alphanumeric characters or underscores. Cannot start them with digits. So here I could just say int JSON, and then I have a semicolon to end the declaration. And that's how you declare a variable. And now if I wanted to initialize that variable, which you should do during the declaration, you just use the equals operator and you specify the right type of data. So int is a decimal, so I have to say a number. I can't put a word in here because I didn't specify a word. I specified a number and that would give a compiler. But all you have to do is specify based on the data and then a semicolon. Remember semicolons and the statements, and that's initializing and declaring a variable on the same line. You could also assign values to variables later in your program. So I could just declare it and I could actually initialize it. Let's say it's equal to 5, and then I could overwrite it in another line. I could say JSON equals 8. I want to change the variable because variables can change values. We are assigning data using the equals operator, and you will notice that there's no data type on the line foot. All we have to do to access that the name to modify it. We'll talk more about the equals operating than we talk about data, but this is the basics for variables. They represent data in your program stored in memory accessed via variables using these naming conventions and initialized and